All right, let's jump right in. We're going to talk about a molecule that you've almost definitely heard of, creatine. But I'm willing to bet it's not in the way you think. We're going to peel back the layers on the incredible science of how this thing powers, well, pretty much everything you do. So when I say the word creatine, what's the first thing that pops into your head? Probably something like this, right? Big tubs of white powder, stuff for bodybuilders, or maybe elite athletes trying to get an edge. And look, you're not wrong, but that's just the tiniest piece of a much, much bigger story. Because creatine really isn't just about building bigger muscles. It's actually about a fundamental problem that every single one of your cells, from your brain to your biceps, has to solve every single second. It's all about energy. So what is this big energy problem? Well, we can call it the cellular energy gap. See, your cells have these incredible power plants, but they have a critical weakness. There's a gap between when your cells scream for energy and when they can actually get it. To get this, we've got to talk about ATP. The easiest way to think about it is like cash. It's the currency your cells use to pay for absolutely everything. Every muscle twitch, every heartbeat, every single thought you have. It is the universal energy currency of life, period. Now, your mitochondria are constantly churning out this ATP cash, kind of like a power plant supplying electricity to a city. But here's the catch. They're built for the long haul. Like a marathon runner, they provide slow, steady energy. So when you suddenly need a massive burst of power, like sprinting across the street or lifting something heavy, your mitochondria just can't spin up fast enough. There's a lag. So to solve this, your cells developed a brilliant two-part system. You've got the mitochondria, the slow and steady power plants, but you've also got this other thing, phosphocreatine, which acts like a fully charged battery backup, ready to deliver instant power the second you need it. It's what bridges that energy gap. And the really cool part is just how simple and ridiculously fast this is. Okay, so your energy demand spikes, an ATP molecule gets spent. Phosphocreatine just swoops right in, hands over its phosphate, and bam, you instantly have a fresh, fully recharged ATP molecule ready to go. We're talking fractions of a second. It's what keeps the lights on when you need them most. Okay, so that's how it works. Now let's talk about where it works, where this instant energy system makes the biggest difference. And it really comes down to the two most energy-hungry tissues in your entire body, your muscles and, you guessed it, your brain. Now, in muscles, the effects are pretty well known. More creatine means a bigger, better battery backup. This lets you generate more strength and more power. It helps you push off that feeling of fatigue during a workout and helps you recover faster between efforts. And this is so important. It's not just for young athletes. Research shows it's a huge help for older adults in fighting off age-related muscle loss, which is critical for staying healthy. Now, if the story ended right there, it would still be pretty important. But this is where things get really fascinating, because muscle is only half the story. I want you to just let this number sink in for a second. 20%. Right now, as you're just sitting there, your brain is burning through 1/5 of your body's entire energy budget. It is an incredibly expensive organ to keep online. And just like your muscles in the middle of a heavy lift, your brain cells, your neurons, constantly face these moments of massive, sudden energy demand. Thinking hard, trying to focus, dealing with stress, all of that requires the exact same instant access to ATP. Your brain has the same energy gap problem. So, what happens when you give the brain's energy system that same support? Well, the research is pretty compelling. It suggests that having more creatine available can improve things like memory and how fast you process information. It can boost your focus during tough mental tasks, and this one is huge. It can help your brain stay resilient when you're stressed out or sleep deprived. This brings us all the way back to the beginning. It's time for a complete reframing of what creatine actually is. We need to move way beyond the view from the gym and see it for what it truly is on a basic biological level. So let's be super clear. Here's what creatine isn't. It's not a stimulant like caffeine. It's not some weird exotic performance-enhancing drug. And it is absolutely not just for bodybuilders. So what is it? It's a core piece of your basic cellular infrastructure. It's a fundamental support system for any high-energy tissue, which includes your muscles, yes, but also your brain. And you know, that really is the perfect way to sum it all up. There's nothing flashy about creatine. It doesn't push you or hype you up. It just works. It quietly supports the most basic energy systems that your cells rely on to do their jobs. It's not flashy, it's just fundamental. Which kind of leaves us with one final thought to chew on. If a molecule as well known as creatine has been so narrowly misunderstood for so long, What other basic, absolutely fundamental parts of our own biology might we be overlooking, hiding in plain sight?